You take it. Tell that. Good morning, learners. How are you all? Okay, let us wait for a minute or two for all the people to join. Good morning, Manvit. Good morning, Nirant Gowda, Lalita K, Snehasri, GS Rockers, Purnima Upparige, Manjushri M. Good morning, Mahadeva. Good morning. It's better if you mention your names. I think ID is created using some other name. Bharat Reddy, good morning. Suchitra, good morning. Kemparaju, good morning. Suresha Gowda, good morning. Kritika, good morning. Maheshwara or good morning. Sneha Shri, good morning. I am good. How are you, Sneha Shri? Murali Karthik, good morning. Kaustubh, I'm good. Good morning, Kaustubh. Sahana Suresh, good morning. Kumar Kaushik, good morning. Nakul, good morning. Anero, good morning. Nirant Gowda, good morning. I already said Nirant twice. Okay. Shall we start? Kirti Gaudru, good morning. I'm good. Murli Karthik, how are you? Bharat Reddy, I'm good. How are you? Manvit, Manasa, good morning. Srishti Eti, good morning. Nagaraj, good morning. Okay. So, yesterday we discussed Bayes' theorem, right? So, we will solve some problems today. I want to take one problem, exercise first problem, because that is very, very important because it was asked multiple times in JEE. Similar question. So let us take it up. The first question, and as I said that you have to use diagrammatic approach to make the simple problems very simple. Okay. 13.3 first one. I don't know if you have done it. Even if you have done, please look at this. An urn contains 5 red and 5 black balls. This is basically total probability question. So whenever you read the statement, just visualize. Urn means container. In this, you've got 5 red, 5 black. A ball is drawn at random. So from here, you are picking a ball at random. So you may get red ball or you may get black ball. Two scenarios possible. That is red ball or black ball, right? So that also you can visualize. A ball is drawn at random, its color is noted and is returned to the urn. Moreover, two additional balls of the color drawn are put in the urn and then a ball is drawn at random. Please look into your textbook, page number 555 or the soft copy which we have sent. So here, once you pick a ball and then whatever you note down the color, what color that you have got, and then you put back that ball into this. Moreover, two additional balls of the color drawn are put in urn. What does it mean? Suppose if you have got the red ball, what you will do, so same container basically, you put back this red ball and you will add two more red balls. Whatever color you get, you have to add two more of that same color. So what does it mean? 5 red balls will become 7 red balls. Black balls as it is, because you have not done anything for this. Suppose if you get the black ball, what you do? You will put back the black ball, then you add 2 more black balls. That is the given data in the problem. So your red balls will be 5, but black balls will become 7. So this is the thing. Now, what is the probability that the second ball is red? Here what you are doing, moreover, two additional balls of the color drawn are put in the urn and then a ball is drawn at random. Now in this scenario, you are picking the ball randomly. You may pick from this scenario or from this scenario. So what is the second ball is red? Probability of second ball is red. Means you have to get from this scenario. Okay. Now, to get the second ball red, you may get this scenario or this scenario. See, or, the word, remember, or means addition. Whenever you see and, it is multiplication. Please remember this. So, addition theorem or multiplication theorem means adding two probabilities or multiplying two probabilities. Suppose if you want to get the red ball here, the second scenario, it is red ball. You wanted red ball here, right? So if you want the red ball, here also you want a red ball, here also you want a red ball. So it's of course same. Second ball is red means from this scenario or from this scenario. Or, so I'm using or here. But if I want red here I should be getting red. Here also I should get red. Red. Here first I should get black ball, then red. And so my required probability will be, here tell me what is the probability of getting red ball for the from this. Total how many are there? 10. How many are favorable for red? 5 by 10. That is 5 by 10 is nothing but 1 by 2. What about getting black ball? Total 10 balls. 5 are favorable to black. That is 1 by 2. Right? Now, in this scenario, what is the probability of getting red ball here? Total 12 balls are there. So, shall I write here? Total 12 are there. 7 divided by 12. 7 are favorable for red. Here also 12 are there total. But how many are favorable for red? 5. 5 by 12. So for this scenario, this and this should happen. So that's why multiplication theorem. 1 by 2 into 7 by 12 plus for this scenario, this into this. This should happen and this should happen. So R, either this scenario or this scenario. Therefore it is plus. So 1 by 2 into 5 by 12. 5 divided by 12. So now LCM is 2 into 12, that is 24. 7 plus 5. What is 7 plus 5? 12. 12 divided by 24, that is 1 by 2. 1 by 2. So that is the required probability. So this is the textbook exercise 13.3. Exercise 13.3 first. So many times in JEE mains, in JEE, they've asked the question based on this concept. So shall I dictate one question? That is, yeah. So take down this. So using diagram becomes your problem becomes very simple. Even in CET also, you can expect this kind of question. This is basically total probability problem. So intersection of these two things plus intersection of these two things. Intersection is and. So can I dictate the problem for you, JEE mains problem? Please take down. I'll also write here as there may be confusion. If I dictate, I'll just write down. Where is the clock, please? So I will arrange this diagram at least. If somebody is writing down, let that be there. Same, language also similar. An urn means container. An urn, JEE question. An urn contains five red, five red, five red, five red, and two green balls. An urn contains five red and two green balls. A ball is drawn at random from the urn. A ball is drawn at random. At random from the urn. If the drawn ball is green, if the drawn ball is green, then a red ball is added to the urn. Then a red ball is added to the urn. The previous problem, if you get the drawn ball is green, you will add the only green balls. But here, if you get the green, you have to add red ball. And if the drawn ball is red, if the drawn ball is red, then a green ball is added. Then a green ball is added. The original ball is not returned to the urn. Here you see there the original ball is returned. Here the original ball is not returned to the urn. So you have to understand this clearly. Now the question comes. This is the scenario. Now the question is, now a second ball is drawn at random from it. A second ball is drawn at random from it. The probability that the second ball is red, the probability that the second ball is red. This is the question. So what we will do, we'll draw the similar diagram. Then the problem becomes very easy. One step. So an urn means container. It contains 5 red, 2 green. A ball is drawn at random from the urn. Means you may get green ball or you may get red ball. If the drawn ball is green, suppose if you get the green, then what you do? Then a red ball is added to the urn. So red becomes what? 6 red. And if the drawn ball is red, suppose if you get red, then a green ball is added. Green becomes 2 plus 1, 3 greens. The original ball is not returned. Means what? Suppose if you have drawn green, you don't return that one. Means only 1 green will be there. Here if you get red, you don't return the original ball. So what you'll have? 4 red. So this is the scenario. Now a second ball is drawn at random. What is the probability that second ball is red? Probability that second ball is red. Please understand here, I don't have 3 urns like this. Same one urn only, all this is happening. But you are making it clearly. This is what is happening here. So here, what is the probability of getting green? First thing, total 7 are there. So 2 by 7. What is the probability of getting red? 5 are there. So 5 by 7. Now here, what is the probability of getting red? So 6 total 7, 6 plus 1. Here 4 red out of 7. So now if you want this scenario, this and this should happen. That is 2 by 7 into 6 by 7 plus, if you want here red one, so this and this should happen. Here it is this or this. So that's why plus. So 5 by 7 into 4 by 7. So 7 into 7, 49. 6 to 12. 12 divided by 49 plus 20 divided by 49. That comes to 32 divided by 49. The given options are A, 27 by 49, B, 26 divided by 49, C, 32 divided by 49, D, 27 divided by 49. So the answer is C. I hope all of you understood this. Isn't it? Simple now. And many times, this kind of concept was asked in IIT. Good. Many people are giving the answers. 32 by 49, C, etc. Good. Very good. So can we move on? So is there any problem which you want me to solve? You please tell me. But one problem I'm interested to discuss because that is related to our current scenario. As you know, coronavirus is attacking people and people are going to hospital for the test. And do you know, first time if corona test comes positive, definitely doctors will not declare that it is positive. They will suggest the patient or patient only will ask, please do the test second time. Do you know what is the reason behind that? So we will understand that. Can I raise this? Suppose first time if somebody gets positive, it doesn't mean that he or she has got disease. Not only for corona, for anything. So your textbook example, I don't know whether you have seen this problem. All other problems are very easy. You can easily identify the partitions and you can do. Maybe these problems you need to probably think how to put the partition. Example 18. I can solve either example 18 or in the exercise. Example 18 anyway it is there in the solution here. I would solve exercise 5, a laboratory blood test. Okay, can we solve that? So I will read out for you page number 556. A laboratory blood test is 99% effective in detecting a certain disease when it is in fact present. You know what does it mean? All these tests, what happens in the diagnostic labs, they are not 100% accurate. So what they are saying is it is 99% accurate. Means 1% error is possible in that. What does it mean? Because of that error, if you go, you don't have the disease. But if you undergo that test, it may gives you positive because there is a defect in that machine. So here in this test is positive means people have got the disease. If test is negative means people don't have the disease. Please remember that. Here it is in opposite values. Laboratory test. Positive means disease is there. Negative this is there. Negative means no disease. Negative means no disease. Positive means disease is there. That is the terminology that people use in hospitals and diagnostic labs. So what we are telling is the machine which tests blood test, that is 99% effective. Next. However, the test also yields a false positive result for 0.5% of the healthy person tested. So what they are saying? 0.5% of the health. Suppose if somebody, like there are 100 people, out of 100 people, 0.5% means off mark. You cannot take. Let's take 200. If 200 people tested, 0.5% means 1%. This 1%, he doesn't have the disease, but the test shows that person has got a disease. That is another data that they are telling. This is a false positive result. Next, if 0.1% of the population actually has the disease, how many people have got the disease? 0.1%. Okay, all this data you have to remember. Means out of 1,000 people, only one person has got the disease. That is 0.1%. What is the probability that a person has the disease given that his test result is positive? Now, somebody goes to the hospital and takes the blood test or whatever test it is, and a doctor says that yes, result is positive. Now you have to tell what is the probability that actually he has got the disease. Means you will be surprised to know that it is only about 15 to 20% that person has got the disease. So let us see how it comes. Okay. So probability, through probability we'll understand why there is a less probability that person is actually having the disease. So for that you need to use diagrammatic approach. Don't have the new pen. This is in real life generally we use these things. Okay, that's why you need to understand the importance of probability. Here, what is the partition that you make? That's very important. Here, the people who have got disease, that's the partition you make. Two partitions. One partition is people who has got disease. Another partition is people who do not have disease. So here we are telling that if 0.1% of the population actually has a disease, how many people? 0.1%. Here it is percent. If you want to express in terms of decimal, then you have to put 0.001. You can use this or this, whichever you are comfortable. What does it mean? 99.99% do not have the disease. 99.99% do not have the disease. If you want to put it in decimals, it is 9999 divided by 100. This, so E1, let's call this as E1. This is E2. Here, population who has got disease, population who do not have disease. Now, a person goes to the hospital and he gets tested. Person might be going with actually having the disease or not having the disease. So like this. This is event A. Generally, you take this event A. So what is this event A? What is the probability that a person has disease given that his test result is positive? So probability that a person, here test result is positive. This event A is test result is positive. Test result is positive. You got the test result positive. Event A. Now you have to tell what is the probability that this person actually has got the test. What does it mean? Sorry, actually has got the disease. What is the probability that when the test result comes positive, that actually has got the disease? What does it mean? He should have come from this zone. That is where disease is there. It is E1 is population disease. Okay. Yeah. Disease. Here E2 is no disease. E2 is no disease. Suppose if the person comes from this, even though you get the test result is positive, but he doesn't have the disease. That is the meaning of this. So what you have to find here is what is if test result is positive and actually he should have the disease, means what? He should have come from this. So what you need to find is probability of E1 given A. So you know the formula. So you'll put like this. Here there are two partitions. So denominator probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. This is a standard formula. Numerator, what you get? This one. That is probability of E1 into probability of A given E1. Now, just substituting the values here. So, let's see. First, probability of E1, that is this one, 0.1%. Should we use percentages or decimals? Let us use decimals, okay? Or percentage also you can use, doesn't matter. Okay, percentages also you can use. Okay, let us use percentages only. Because here percentage, and divide by 100 gets cancelled anyway. Okay, you can use this only. 0.1% into, that is probability of E1. Probability of A given E1. So means somebody goes to the test from this. What is the probability that he will be tested positive? 99%. Because the test is, effectiveness of the test is only 99%. It cannot detect 100%. So therefore it is 99%. That is 0.1 into 99 divided by, because that is there in the problem. 99% is effective. Next, 0.1 into 99. This as it is you get. Next, look at the second thing here. E2. What is the E2 probability of the people not having disease? 99.99. And now somebody goes from this, but still this test gives you a positive result. That they said 0.5% of the healthy person tested, it gives false positive result. So that is 0.5%. 0.5. Just simplify this one. You can use calculator. What you get is 16.528. 16.528%. So what does it mean? That is, even though if the person is tested positive, the probability that he actually has got the disease is 16.5%. It is very, very less. So that's why doctors always suggest patients to go for second time. I read one story in London. I think when a famous cine actress, she went for this coronavirus test. First time she got positive. So she went actually 5 times, but unfortunately, all the 5 times she got positive. So now it is confirmed that she has got coronavirus. So you can see the example 5 also, something similar. Okay, I think having done these problems, so I can also do one more problem, which is you may find it difficult. All others, it's easy to identify the partitions. Once you identify the partitions, just substitute it in the formula. So one problem which you may find it difficult is exercise 12th problem. Okay, let us do that problem. So can I erase this? Okay. Okay. Is it visible? Is it visible? Okay. 12th problem. Understanding the problem, you may find it is based on the playing cards. You may find it difficult. That's why I want to take it up, this question. It says, a card from a pack of 52 cards is lost. So you have a set of 52 playing cards, and now you have lost one card. From the remaining cards of the pack, two cards are drawn and are found to be both diamonds. Full stop. Find the probability of the last card being a diamond. You understood? Please read this. I will put it in the form of diagram. So you have got a playing cards, set of 52 cards. From this, you have lost one card. Then remaining will be what? Total 51 cards. So here the question is, a card from a pack of 52 cards is lost. From the remaining cards of the pack, two cards are drawn. Okay. From this, now you are picking randomly two cards. 1 and 2. Find the probability of lost card being a diamond. So you have to tell that whatever you have lost, one card you have lost, right? This, what is the probability that it is diamond? That you have to tell. So how do you create partitions here? That is the key thing here. So the partitions here is, imagine that you have lost diamond card. Okay, diamond card is lost. Remaining, not that. It's not the diamond card. Some other card is lost. So your partitions E1 is diamond card is lost. E2. This is E2. Here, not a diamond card. It could be anything. Not a diamond. There are many other cards. Now, how many diamond cards will be there in a pack of 52? 13. So, what is the probability that diamond card is lost? That is probability of E1. Probability of E1. 13 out of 52. That is your 1 by 4. So, this is actually 1 by 4. What is the probability that not a diamond is lost? That is 1 minus 1 by 4. 1 minus 1 by 4, that is 3 by 4. So we call it as probability of E2. Probability of E2 is 1 minus 1 by 4. Our remaining cards actually, that is 39 by 52. You get 3 by 4. So is it clear? Now, you have got total 51 cards. From that 51 cards, you are picking 2 cards. You are picking 2 cards. From the remaining cards of the pack, 2 cards are drawn and are found to be both diamonds. So now you got this event A. Event A is what? 2 diamonds you got. You got 2 diamonds. Diamond cards are drawn. So when you picked 2 cards, both you got 2 diamonds. 2 diamond cards are drawn. Now, what is the probability that the last card is a diamond? What does it mean? So you should have got it from this one. Probability of E1. Probability of E1 given that you got this event happened. So write the formula. So E1 means top you will get E1. Probability of E1 into probability of A given E1 divided by. Probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. So, what is the probability of E1? 1 by 4. Here, probability of A given E1. Now, what is the probability that you get 2 diamond cards? Given that, one diamond card is lost. Means total how many cards are there? Total 51. And how many diamonds will be there? Because now you are even. Diamond card is lost. So, you'll have 3 diamond cards into. Next, second card also is diamond. But total how many will be there? You have picked one here, 50. And now how many diamonds? 2 diamonds. Divided by. Same thing you'll get here. Did you understand this? I'll explain once again. 13 diamonds. Yeah, sorry, 13. I'm sorry. 12. Yeah, I'm sorry. I'm taking it as 4. Sorry. Total 13 diamonds. Out of 13 diamonds, one card is lost. So 12 for the first diamond. Now you need to get the second card also. 2 diamond cards are drawn. For first diamond card, it is 12 by 15. For the second diamond card, it is 11 by 50. 11 by 50. Okay. Now here, same thing you'll get 1 by 4 into 12 divided by 51 into 11 by 51. So sorry, 50. Plus, now here you see, probability of E2, that is 3 by 4. Now here, you have to be very careful. You have not lost the diamond cards. Means, other than diamond, you have lost. So, out of total cards, how many are there? Total 51. Now, how many diamonds are there still? Not lost. One card is lost. It may not be diamond, but some other card is lost. So, total number of cards is 51 now. But how many diamonds are there? 13 into. For the next card, 12. So, this is the thing. If you simplify this, you'll get the answer. You see here, 4, 51, 50. 4, 51, 50. 4, 51, 50. So, it gets cancelled. So, what is remaining is 12 into 11 divided by here 12 into 11 plus here 3 into 13, 39 into 12. So here, smart way of calculation. You see here, 12, 12, 12. Everywhere it is common. So you can take 12 common here, 12 gets cancelled. So what you get? 11 divided by 11 plus 39. So that is 11 divided by how much? 50. Your answer is 11 divided by 50. This is question number. Yeah, many people are giving the answer here. Very good. Now it is 12:07. I have an option of starting a new concept or solve some more problems on this. More problems. Some more problems. Okay, fine. Can we take examples? You please do it because solutions also are there. So, I'm asking for 8th problem. 8th problem. Okay, fine. Question number 8. So, can I erase this? So, 8th one, what it says, let us see. A factory has 2 machines A and B. past record shows that machine A produced 60% of the items of output and machine B produced 40% of the items. Further, 2% of the items produced by the machine A and 1% produced by the machine B were defective. All the items are put into one stockpile and then one item is chosen at random from this and it is found to be defective. What is the probability that it was produced by machine B? So for you people to visualize, I'll write here a factory. You can imagine a factory, right? So in factory, you have got two machines, A and B. Okay. Machine A produced 60% of the items. So this machine is producing 60% of the items. Larger. Huh? Question number 8. Now we are analyzing the problem. So in a factory, you've got two machines, A and B. A is producing 60% of the items. B is producing 40% of the items. Then it says, further, 2% of the items produced by machine A, here 2% of the products produced by machine A are defective. Here, in machine B, 1% produced by machine B were defective. This is the given data. Now, you have got all the products here. It might have come from A or B, but from that products, you pick randomly one product and you found that it is defective. All the items are put into a stockpile and then one item is chosen at random from this and it is found to be defective. So you got a defective product in your hand. Now you want to know what is the probability that this defective item has come from machine B, from this machine. Okay. So partitions, it is very easy. So your partitions are machine A and machine B. You will call it as machine A is producing more now. So this E1. E1 is basically your machine A. What it is? Machine. Okay, I'll write it down in a bigger font. E1, think of your machine. You are referring to machine A. E2, machine B. Now, lot of products are being produced. How many products are produced by machine A? That is probability of E1, 60%. You can take decimal 0.6 or percent. Probability of E2, it is given. That is 40%, 0.4. Let's take it. Okay, we'll take it decimals. Okay, 60% means 0.6. Probability of E2, 40% means 0.4. Okay. Now, one item is picked randomly from the stock of all the products. And this thing, you found that this is A. This is defective. This is defective product. Defective product is drawn. Now we want to know what is the probability that it is coming from machine B, means E2. So your question is this, what you need to find. Probability of E2 given A. So write the formula. E2 is there. First numerator you write E2. Probability of E2 into probability of A given E2 divided by probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. So this is the standard formula. Denominator you will get everything like this. Okay, now let's put the substitute values. What is the probability of E2? So E1, yes, sorry, E2. First is E2. That is 0.4. 0.4. And they also have said that. So what? Suppose the product is coming from machine B. What is the probability that it is being defective? That they have given. That is 1%. Here 2% defective from A. From B, 1% defective. So that is 1% means 0.01 divided by probability of even, that is 60%, 0.6 into, and here being defective, product is coming from machine 1. What is the probability that it is being defective? That is 2%, 0.02 plus. So probability of E2, same thing here. This it repeats. 0.4 into 0.01. Just simplify this. Whatever you get is the answer. Yeah. You could have put this in terms of percentages also if you want. That is, you could have put like this. Here it is 40%, right? 40% into 1% divided by here 60% into 2%. Here 40% into 1%. So it comes to 40 divided by 60 into 2, 120 plus 40. That is 40 divided by 160. 0, 0 gets cancelled. 1 by 4. That is 0.25. In percentage, if you want to tell, 25%. So you are sure that, I mean, now you are how much sure you are that product has come from machine B is 25%. There is a probability that the defective product has come from machine B. That is 25%, less likely. Okay. Okay. Many people got this. Okay. Okay, Darshan Gowda, excellent question. In reality, what is the use of learning this problem? Explain it, sir. Okay. It is called as critical thinking. Okay. How do you take decisions? It is based on our thinking, right? How do you think? That's very, very important. If you want to think, you need to have certain rational. Okay. So here, now, there is a product that, from, you produce products from two machines. Now you have got all the products actually combined. Now you picked one product and you got a defective. Now you need to guess. That is, what is the probability that this thing has come from machine A or machine B? Now, the probability that it has come from machine B is less actually, 25%. What is the probability that it has come from machine A? Remaining percentage, that is 75%. So there is a high probability that here you are getting defective products more. You see here, first of all, you are producing more products from this machine, and also here defective is compared to this more. Suppose if we take 100 products, out of 100, 60 are produced from machine A and 2 are defective. Or maybe less than that, 2%. For 100 it is 2, maybe less than that. Here it is less of it. So there is a less probability that the product which you have picked has come from machine B. So this kind of conclusions you can make using Bayes theorem. With common sense also, you can um, guess. But with the mathematical approach, you can actually calculate and tell exactly what these numbers are. I'll give you a puzzle for you people based on this. Let's see. Now I'll stop today. This is a puzzle question. Now all of you write down this, and tomorrow you tell me the answer for this. Here, no data. Okay. This thing I found it from internet. One person by name Sanderson. He has got a beautiful site. It is, I think, 1 blue, 3 green. Uh, Today I'll stop with this puzzle. Very interesting. You can also watch this. Maybe first I'll not give the link. I will just give the question to you people. If you want to search answer for this, but don't first you guess and then you search. Simply don't go and see the answer. This one, yeah. The website is yes. Shall I send it through WhatsApp? It is website is actually 3 blue 1 brown. 3 blue 1 brown. A beautiful explanation I'll give. Let me see. Formulas in all of probability. These as needed. Or maybe the most important level is being able to recognize when you need to use it. Yeah, question is this. Write down this. I'll change the names here. I'll give Indian names. Ram is very shy and withdrawn. Comma. Ram is very shy and withdrawn. Comma. I will write it here on the board to be more precise. Ram is very shy and withdrawn. Full stop. Or comma, comma. Invariably helpful. Invariably helpful, but with very but with very little interest in people or are in the world of reality, are in the world of reality. Full stop. A meek and tidy soul. A meek and tidy soul. He has a need. He has a need for order and and structure and a passion for detail and a passion for detail. This kind of description is given about one person. Now you need to tell what is the probability that that person is a, or you guess what kind of person is the librarian or farmer? You need to answer this. Guess, is he a librarian or a farmer based on this description? So this is the quiz today. You think about it. Is he a librarian or a farmer? You give your answer. Then if you want to go and check the answer from that website, I'm fine. You please go and just watch that video, giving some keywords, Bayes theorem. You can give 1 blue, 3 brown. So you will get that. So please go through that. Very interesting explanation they'll give. Okay, as I said that this is a, yesterday also I told you people, some event is already happened. What is the cause for that event? So you'll try to guess using Bayes theorem. Okay. Okay, bye students. See you tomorrow. Oh, some people are telling farmer. Oh, okay. Okay. Give your reasons. You please check that website. Okay, you can answer all of you in the comments. So many people are guessing farmer. Okay, okay. Let us see. Tomorrow I will announce the answer. And you should tell what is the reason also. Not giving the answer. Because you can always guess now. Librarian or farmer. But I don't want just guessing. You need to give the reason for that also. Then you have understood this concept. Okay? See you tomorrow. Bye-bye. Namaste.
Please give your answers with reason in the comments below after the live session has ended.